Hello everyone, today we are going to be talking about the classification of chemical reactions. So there are 5 chemical reactions that we are interested in you being able to identify. The first type is synthesis. So this is a reaction where we combine 2 or more substances to make a compound. So we could think about something like sodium metal, so Na, which is a solid. We can add that to some chlorine gas. Chlorine gas. And if we heat it up really hot, we will get a reaction where we form sodium chloride. And we can balance that reaction like this, and it'll be solved like that. So that's a type of reaction that we can have where we have 2 parts that become 1. So we sometimes use like a general formula where we use letters instead. So A and B can be added together to create something new out of both of those types of elements, A, B. So here's some synthesis reactions that are part of acid rain formation. So here sulfur reacts with oxygen to make SO2. SO2 reacts with oxygen to make SO3. So we get 2 of these and 2 of these to make 2 of those. One SO3 reacts with H2O to form H2SO4. So this all happens in the air. This one particularly happens in clouds. And so this is a way that the acid rain can form. So essentially you get a factory, like my factory looks like a little bit of a fort or whatever, but the factory typically is outputting a lot of debris, and in that debris is sulfur. Sometimes it's sulfur dioxide already, and especially if this was like a coal plant. So in coal, so let's make this we're gonna make it more like a there. Okay, so it's a coal power plant. Coal power. I don't know if that looks anything like a building, but that's okay. And so in the coal, maybe I'll use gray, black. So in your coal rock, you have little sulfur molecules. There's sulfur. I'm going to make them orange so you can see them. So there's sulfur molecules in the rock. And then that sulfur gets burned as we burn the coal, and that produces SO2, goes up into the air, reacts with the oxygen in the air, and then it eventually reacts with the water in clouds, and that's how we get acid rain that comes down with H2SO4 in them. You can even have the SO2 or SO3 sort of fall on the ground, and then water can rain on it, and then it can form H2SO4 in the ground. And this is our acid. All right, now if you have one compound and it breaks down, then that's another way we can go about creating something. And one of the options there is to decompose things like sugar, or we could have the breakdown of, I was trying to think of something that breaks down. You can have the auto-ionization of water. That's a weird one. But if you put water inside of, if you pass an electric current over water, it will actually dissolve. It'll actually break apart and produce hydrogen and oxygen gas. So if you pass electricity through water, you'll see little bubbles form, and those bubbles are actually from the water breaking down or decomposing. So in general, we're talking about a compound that has more than one element, producing 2 different compounds that each have those 2 elements or compounds. So here's an example where we have sugar, and this is like a decomposition of sugar, typically with the presence of oxygen, but it could be done in a bunch of different ways. And this would get all of the energy out of sugar. If you just heated it up in a enclosed container, it would break apart like this. We would have to check to see if this is balanced. I'm just realizing it's not balanced, so here I'm going to put 6 in front to balance those carbons. And then I need 11 of those waters. And those 11 waters means that we'll have 11 oxygens and 22 hydrogens, so it's balanced. Single displacement reactions. This is a type of reaction where one element is replaced inside of another one. So if you, for example, reacted sodium chloride with some lithium metal, you would get a replacement, and the lithium chloride would form and they would be left with sodium metal. So this is typically written this way, where you have A with some other element mixing with with a single element, Y, and then the result is A and Y are now a pair, and the product has the other pairing sort of all by itself. So balance this example of a single displacement reaction. So here we have some aluminum reacting with iron oxide. This is a very exothermic reaction. It's very crazy. It's called I'm drawing a blank right now, but this reaction is incredibly exothermic. Anyways, let's just balance it. I'm obviously have lost my train of thought here. So there are 2 irons on the left, so there's 2 irons on the right, and there are 2 aluminums on the left, and there's 2 aluminums on the right, and the oxygens are already balanced. Thermite is thermite. This is the thermite reaction. Thermite. So if you watch movies from the sort of 80s or 90s action movies, sometimes they use a thermite, a chunk of thermite to hack through a safe or something. And so it's just a mixture of aluminum and iron powder. And if you can heat it up, which is usually the hard part, is actually getting to start. But once it starts, it can like melt concrete. It's very impressive. So another example here is carbon and iron oxide. So that's a mixture of carbon powder and iron oxide or rust. You mix those together and then you heat them up, and the iron will actually come out. So this is one of the reasons why someone working to smelt iron ore, they actually work with like what looks like a very sooty or very dirty work environment. It's because they actually want the dirt, that soot, the black carbon, they need it there to extract the iron from the iron oxide, especially if you're getting ore from straight out of the ground, where most of the iron is already oxidized into its rust form. Okay, so let's start with the iron. We have iron and iron, so I'm going to balance it with a 2, and then I'm going to follow to the oxygen. The oxygens are unbalanced, so I'm going to try to balance them out. I guess I'm going to put a 3 here and a 2 there. Then I'm going to go carbon and say, okay, well, I have 3 carbons, so I need to balance that. And then I'm going to double check everything. So I'm going to go through one more time. Uh-oh, my irons are unbalanced now. So I'm going to replace that 2 with a 4. And I learned my lesson. I should have probably balanced it in a different direction, but you never know. So you just kind of have to do it, do your best, and then just keep following through. Just don't forget to check your answer at the end. Double displacement is where we have 2 chemicals, typically 2 binary chemicals, and then they switch partners. So elements of different compounds replace each other, changing places. This is the general form. AX plus BY gives you AY plus BX. And when we do neutralization reactions, acid bases are a very good example of that. You can have something like sodium fluoride plus lithium bromide, and they will switch partners to form sodium bromide and lithium fluoride. Here we have potassium iodide and lead fluoride. They switch partners. The lead is now lead iodide, and that means that, and there's a potassium fluoride at the end. We just have to do some balancing here, and I'm just going to do a quick 2 and 2 just to balance that out. Iron chloride mixed with potassium sulfide can produce iron sulfide and potassium chloride. What I really like is if you think about the words here, we have iron chloride, iron sulfide, potassium sulfide, potassium chloride. So just really straightforward sort of, when we put the words to it, I think that you can kind of start to see how these things come together. Finally, we have combustion. This is probably the hardest one to balance, but it's the easiest one to write out. Whatever the chemical formula is over here, the products are always the same, carbon dioxide and water. And we also have to include oxygen. So there's usually some oxygen here, but we don't know how much. So if we are given something like this is methanol plus oxygen, then the products are always going to be carbon dioxide and water. Carbon dioxide and water. This is also how you're going to identify combustion. Look for something that has carbon in the reactant and carbon dioxide and water as the two products. CO2 and H2O are always the products. Okay, I'm going to take a quick break and hold off for a second while I wait for you to do the next activity. Classify each as a synthesis, decomposition, single replacement, double replacement, or combustion. So I'm going to take a quick pause. Okay, hopefully you have paused the video and now you are coming back to listen to me give you the answers. So here we have two reactants becoming one. So when two become one, we call that synthesis. Here we have two reactants becoming one, so that is again synthesis. One reactant is becoming two, so that is a decomposition. Two reactants become two reactants, so that's not a synthesis, it's not a decomposition. It must be one of the other options. Here we have an iron by itself becoming an iron with a partner. Here we have a copper with a partner becoming a copper by itself. So there's always one single, right? Always a single, so that means it is a single displacement. All right, we have another single magnesium reacting with H2SO4 to form magnesium sulfate and H2 gas. So this is a single element and a single element. Remember that hydrogen gas is a diatomic molecule. And so that means that this is single displacement. Here we have two products and two reactants. The sodium is matched, the sodium sulfate becomes sodium nitrate. The barium sulfate becomes barium nitrate. I can hear in my own words that there's a swapping of partners with each of those elements, each of those metals. So that swap suggests that there is a double displacement. Finally, we have some carbon product that produces carbon dioxide and water. So this must mean that we are talking about combustion. All right, I hope you can have fun with that. Oh, we do have a little bit more. This one is about balancing, so I'm going to leave that one. We just did a unit on balancing, or a lesson on balancing. I will fill this in as we end the video, and you can come back and check on the Google Classroom for the answers. And with that, we are very close to the end of the booklet. We're going to do a quick environmental connection in the next lesson, and then we'll move on to book 3. Thank you for your time. Have a great day.